Okay guys, welcome back, pre-calc. Today we're going to continue on with our unit circle stuff in section 4.2, and we have two particular objectives. Okay. Now unit circle stuff is challenging, it is tricky, but trust me, if you stick with it, patterns are going to start arising and things are going to start looking familiar. So the first thing we're going to be talking about is the domain and range of sine and cosine functions. Now the domain and range of sine and cosine functions is pretty easy to figure out. All I need to do is to go back to my unit circle. Everything that we're going to be doing is going to be going back to the unit circle and is going to be related to our unit circles. So I'm going to be drawing a bunch of them. Okay, so here we've got my coordinate plane. I've got my handy compass. I'm going to draw my unit circle here. Once again, unit circle is just a circle of radius 1. There. So get my unit circle drawn out. Get my unit circle drawn out here. My compass will agree with me. Okay. So good enough for now. Unit circle. Fantastic. Okay. Hopefully your notes are a little bit cleaner. So unit circle, all I need to think about is, okay, sine and cosine functions. So what I need you guys to have memorized is just that the cosine of any particular angle, cosine of theta is going to be equal to x. When we're talking about the unit circle, cosine of theta is equal to x. And the sine of theta is equal to y. Those are two things I need you guys to have memorized. Cosine of theta is x, the sine of theta is going to be equal to y. Well, if I start thinking about the domain and range, okay, so the cosine is my x values, right? So I'm going to take a look at my x-axis as opposed to my y-axis. So looking at just my x-axis, I can see that I can do lots of things around this circle, right? So my theta, in terms of theta, my theta can get really, really big, right? So say theta is 2 pi, 6.28, which is going to be 1 full revolution, right? So it can be 4 pi, it can be 8 pi, 10 pi, whatever. It can be 10 billion pi, just many, many revolutions, okay? So theta can be a lot of things, okay? So theta is not limited whatsoever by the cosine function. So it can be positive, it can be negative. So basically, the domain of the cosine function, cosine of theta, has domain from negative infinity to infinity. And this doesn't matter if I'm talking radians, if I'm talking degrees, whatever. The domain isn't limited. However, the range is. Okay, so the range is what my x values are going to be, right? So theta is spinning around. Now my x values are going to be associated with the range in this case. Now my x values are very much limited. They're limited to these values in between these two lines, right? Because it can never get outside of this. It always has, it can be less than this. It can be less than this number right here, right? So for example, it could be this number, it could be this number, it could be 0, it could be a little bit more, a little bit more, a little bit more, but then it's stuck over in this direction as well. So the range I'm seeing is limited in this direction. So the range can't be anything more than negative 1 on the low side. That's going to be over here because I'm talking my unit circle, right? It's got radius 1. So this is 1, 0. This is negative 1, 0. So it's stuck between negative 1 and 1. That's the range of my cosine function. Now I can do something really, really similarly with my sine function if I take a look at it. So same thing, I'm looking at theta, and theta could be any particular angle, right? So as theta is increasing, right, it can be negative numbers, it could be decreasing, it could be increasing, whatever. Theta is just spinning around. So once again, its domain is not restricted. Negative theta, comma theta. or not negative theta, negative infinity to infinity. So the domain is not restricted on the sine function. However, the range, similar to exactly what we did with our x values, the range is limited. So in this case, my range is limited. It's got a high point of up here, which sure enough is 0, 1. And here is 0, negative 1. So looking at the y values, the y values can never be higher. No matter what theta is, y values can never be higher than 1 and can never be less than negative 1. So the range of my sine function is stuck between negative 1 and 1. So this is the domain and range of my sine and cosine functions. Okay, let's draw a line there. Now, moving on, we're going to be talking about the exact values of the trigonometric functions and how to find them. Exact values of trig functions. Now this is how you do this without using your calculator. And this is what I'm going to push you guys to do. Solve these without using your calculators. Now the value in that is it requires a deeper understanding of what the material is talking about, deeper understanding of what is going on. So the exact values of the trig functions. Say I've got some coordinate plane, right? And surprise, surprise, in a little bit I'm going to be drawing a circle on here. But say I've got some coordinate plane, x and y. And I'm wondering, okay, I'm looking at what happens when theta is equal to pi over 4. Right? This is going to be an angle that pops up a lot. So theta is going to be equal to pi over 4. Or for those of you that want to go ahead and do the conversion, pi over 4 times, you go 180 over pi is going to be equal to 45 degrees. Now 45 degrees is a particularly interesting angle because that is exactly where, if I was to plot this on a line, this would be where y is equal to x, right? So it's just a linear function. So instead of y is equal to mx plus b, in this case my slope is 1 and my b is 0, 0. So it crosses the origin and it has a slope of 1. Right? So this is my y is equal to x line. This is a very special line that pops up all over the place. And sure enough, my theta at this point cuts it right in half. It's going to be 45 degrees or pi over 2. Okay, so y is going to be equal to x. Now, what is the value? Here's a question that I want to try to find. Is what is the value of the unit circle? Let me make my unit circle a little bigger. What is the value of the sine and the cosine of pi over 4? This is what I'm looking for. The value of the sine and the cosine at pi over 4. I know it's spinning. Give me a second. Okay, so I know what pi over 4 is. I'm looking for the sine of pi over 4. Now, before you reach for your calculators, we can figure this out. I'm also looking for what the cosine of pi over 4 is. Now, I'm going to walk us through this derivation. It's going to be equal to something. It's going to be equal to something. I'm going to walk us through this derivation, try to explain it. And the idea is that you have a deeper understanding of what the unit circle is and the power behind it. Okay, so the first thing I need to notice, and I can solve this a couple different ways. First off, I'm looking for this point right here, that point. And this is going to have some x, y value. Okay, I have no idea what it is. Actually, I do have a pretty good idea what it is. But at this point, let's pretend. I don't have any idea what it is. How do I figure this out? Okay, so the first thing I notice is that the equation of the unit circle, the equation of any unit circle, is x squared plus y squared is equal to 1, or the radius squared. In this case, my radius is going to be 1, because I'm at my unit circle, 1, 0. So my radius is going to be 1, so 1 squared. Now this also really jives if you want to think about it in terms of triangles, right? So if you want to think about it in terms of triangles, here I've got a triangle, okay? I've got some value x right here. I've got some height y, and I'm looking for the hypotenuse h. So I could say, okay, x squared plus y squared is going to be equal to h squared. But holy cow, my h, remember the radius of my circle is just going to be 1. So this is just going to be 1 squared. And so then I can just say x squared plus y squared is going to be equal to 1. And this are exactly the same. So circles, triangles, we're starting to see a lot of similarities between the two. Now, let me charge forward. Since I'm looking for this point xy, and I know that y is equal to x, I've got this equation here, x squared plus y squared is equal to 1. I can plug this relationship in, y is equal to x. So here I've got x squared plus y squared is equal to 1. Since I know that x is equal to y, I can just say x squared plus, now y is just equal to x, so I can just say is plus x squared is equal to 1. So simplifying this, I can combine my like terms. So I end up with 2x squared is equal to 1. Solving for x, I divide by 2 on both sides. I get x squared is equal to 1/2. Now I can take the square root of both sides. Taking the square root of both sides, I just find out that I get x is going to be equal to the square root of 1/2. Okay, this might start looking a little bit familiar, but if I wanted to rewrite this, okay, so I'm going to come up here, trying to keep today's notes all on one page. X is going to be equal to the square root of 1/2, which is going to be close. So I take the square root of the top and the bottom, and the square root of 1 is just 1. So I just get 1 over the square root of 2. Now I don't ever like having a rational in the denominator, or a square root in the denominator. So in order to get rid of this, I can just multiply the top and the bottom by the square root of 2. Okay, so the square root of 2 times the square root of 2, that is actually just equal to 2. Okay, so this is just going to be equal to, and then on the top I have 1 times the square root of 2. So I just end up with square root of 2 over 2. So my x value is equal to the square root of 2 over 2. And because I know up here my relationship is y is equal to x, or x is equal to y, I know my y value has to be exactly the same. So my y value is going to be equal to the square root of 2 over 2 as well. Now how does this solve my initial problem? I'm looking for the sine of pi over 4 and the cosine of pi over 4. Well, I remember that the cosine of my angle is my x value right here. Now my x value is square root of 2 over 2, so the cosine of this angle, of this pi over 4, is just going to be equal to the square root of 2 over 2. Right? Cosine is associated with the x. Now the sine is associated with the y, so if you guys haven't figured it out yet, the sine value is going to be y is equal to the square root of 2 over 2, or the sine of pi over 4 is equal to the square root of 2 over 2. So here we go. We're filling out our unit circle, our ever important unit circle, figuring it out one angle at a time without having things memorized, just deriving it from what I know about the unit circle and angles and triangles and fun things like that. Okay, so we'll pick this up in class tomorrow. I want you guys to be able to be comfortable with this and figure out how to find angle measures, or given an angle measure, how to find xy coordinates, particularly with that pi over 4 one. That's going to be pretty critical. All right, I'll see you guys then.